Lesson 1.5 day 2 is all about variables on both sides again, and we're going to focus a little bit more on some word problems. All right, we're going to talk about different amounts of solutions as well. So objective is still the same as yesterday, write and solve equations with variables on both sides. And at the top right here, it says equations, and then it has blank blank, always have one solution. Lately, we have done equations where we solve and we only have one solution, like x will equal 2 or x will equal -5, all right? But equations do not always have one solution. We're going to talk about that a little bit in this first part. Okay, so we're going to determine in 1 through 6 if, determine how many, not if, let's cross out the word if, determine how many solutions there are. A little typo there, sorry about that. So this first one, we have 3 times 5x plus 2 equals 15x. What are we going to do first? Distribute. Good. What operation do we use for distributing? Multiplication. Perfect. So we have 15x plus 6 equals 15x. And remember, keep your equal sign lined up. That's keeping yourself organized. And now I have variables on both sides. We did this the other day. I want to get them all on one side. On the left, I have a variable term, 15x, and a constant of 6. On the right side, I only have a variable term. So I actually want to move my 15x on the left over to the right. If I have 15x and I want it to be 0 x's, what do? Yeah. Minus 15x. And to keep it balanced, right? So I just made the left side lighter by taking away 15x. I got to do the same thing to the right side. So we have 0x plus 6. Well, that just gives me 6. And on the right side, I only have 0 x's. If I have 0 x's, what is that really? Just 0. Do I have to put the x there? No, I could just write 0. Is this a true statement? Does 6 equal 0? No, when it's untrue, put a slash through that equal sign. That means it is untrue. If you want to also write the word false for your notes, that is fine, okay? When we get a false statement like this, telling me that two numbers that are obviously not the same number are equal, then there is no real solutions. Okay, and they already wrote the word solutions for you. No real solutions. That happens sometimes when we get this false statement. Next one, number 2, we have n divided by 6 equals negative n over 6 plus 1/2. I have 2 n terms, again, on different sides, so I want to move to get them combined. If I have, I'm going to zoom in here. If I have a negative n over 6, that is a like term with this n over 6. I want it to be 0 n over 6. So how do I do that? Add it, yes. Opposite or the inverse operation of subtraction is adding. So we're going to add n over 6 to both sides, plus n over 6. What number is really next to my n? We just don't write it. 1. So it's really like 1n over 6 plus 1n over 6. Well, the 6 is the same denominator. That allows me to add them just as they are. And then my numerators, what's 1n plus 1n? 2n. Perfect. And we can even go a little further in a moment and simplify if we want, but I'll simplify at the very end, okay? So if you want to simplify now, you absolutely can. I'm just going to wait a little. Okay, on the right side, this guy becomes 0, n, which is just 0, plus 1/2 is still 1/2, okay? Now here, I have my n in the numerator. I have a 2, I have a 6. Here's how we get rid of a fraction being multiplied, not adding or subtracting, okay? Right now it's being multiplied 2 over 6 times n. In order to get rid of that, I'm going to take the 2 and put it in the denominator, and I'm going to take the 6 and put it in the numerator. I just flip it. That's called your reciprocal. Here's why it works, okay? What is 6 divided by 6? 1. What's 2 divided by 2? 1. Are we left with 1 n now? Yeah, that's why it'll work. Now, just like any scale, I did something to the right side. I got to do that same thing to the left side. So I'm going to take it, and I'm going to do 6 over 2 there as well, and I'm multiplying it. Multiplication of fractions, we just multiply the top numbers with each other and multiply the bottom numbers with each other. What's 1 times 6? 6. What's 2 times 2? 4. Okay? Can we simplify this guy? Yeah, what does he reduce down to? 3 over 2. Good. Or I heard a decimal version as well. Is that what I heard? Was it 1.5? All right. I don't care which fraction, reduced fraction, or decimal you use. I'm okay with either one. Big Ideas usually has you write it in simplest fraction form, so they would accept the 3 over 2. But on a quiz or test, I'll accept both because they're equivalent. So when we get down to here, this is what we normally get. We get an n is equal to some number, okay? That means there is only one solution. And you can even cross off the s, okay? One solution. You only have your n is equal to 3 halves. Your n is equal to 1.5. Now I know there's an or. Are those two different numbers? No, they have the same exact value, okay? That's why it's still just one solution. Last one here, number 3. We have negative 2 times the sum of 4y and 1 equals negative 8y minus 2. Just like the first one, what do we have to do first? Distribute. Awesome. And distribute means multiply. When you multiply a negative number with a positive, what do we wind up with? A negative. Very good. So we have negative 8y minus 2 equals negative 8y minus 2. That's interesting. What do you guys notice about those? Yeah. Nothing's different, correct? Every single piece of that is the same. The negative signs are the same. The numbers are the same. The variable is the same. There's not a single thing that is different when you have the exact same copy-paste version of each other on your equal signs, okay? They will have infinitely many solutions. Because they are the exact same equation. So any number you put in there will work and be true. I could pick imaginary numbers, honestly, if I wanted to, and it would still work, okay? So any number I select would work. That's infinitely many. And it's only that way if it is exactly the same, okay? It cannot differ at all right? I'm going to have you guys try 4, 5, and 6, okay? You can work with your neighbor. So no real. What were the final numbers that you got there? 72 is not equal to negative 112, you said? All right, yeah, definitely not equal. Definitely false there, okay? What about number 5? One solution? What was your final answer there that you guys got? J equals, what was it? 1. Awesome. Okay. And then what about the last one? Ooh, that's a tough one. Do we want to do that one together? All right, let's do it. Okay. All right. So let's look at number 6. We have C over 5 plus C over 2 equals 7 over 10C. Okay. What number is really next to these C's? 1. Okay, so we really have 1C and 1C there. Okay, so 1C over 5. Remember that we can write it just like the 7 over 10C. I can write this pulled apart like this. That means the same thing. 1/5 C plus 1/2 C equals 7/10 C. That is allowable, okay? I'm still technically, it's like I unmultiplied them, okay? I undid it. I just separated it only because my 1/5 C and my 1/2 C, I can actually add those coefficients together. My coefficient here is 1/5. So we can take 1/5 and add it with 1/2. Okay, those are coefficients. They are like terms. So do that. 1/5 plus a half in your calculator. And I want it in fraction form only because the other side is 7/10 C, and it's easier to compare my fractions if they're both in fraction form.
7/10.
Awesome. 1/5 plus a half is also 7/10. Good. So what would we say? Infinitely many. They are the exact same thing. So we have infinitely many solutions there. Okay? They wind up being the same. Let's check this guy out. It says, a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Okay, so Miss Aaron's not an artist. Okay, so we're starting here. Start. And here's my boat. And here's my water. And we arrive eventually right at our destination. End. Okay? That's my beautiful picture. Now, I'm going to pull out some information. They said the boat leaves, right? And it takes them going upstream 4 hours. So I'm going to write T equals 4 for the 4 hours, right? That's our time. And I'll even do a little arrow so I know that I'm talking about upstream and not downstream, okay? So it's like a ferry. We take a ferry to a location, we stop, we do whatever we need to see there, and then it says, okay, then on the way back, so the same path, right? The same path, but on the way back, it took less time. It only took them 2.8 hours because it traveled 3 miles per hour faster downstream. Okay, so I'm going to write my time, and we'll do it over here. T equals 2.8 for that 2.8 hours. And I'm going to draw my little arrow and write down because we're talking about our downstream. And I'm even going to change that to same color blue. There we go. All right. Everybody knows a current. What does a current do? If we're going with the current, go ahead. It takes you, right? Yeah. Anybody ever swim the ocean? They're like, be careful of the current, right? Or the riptide. Swim parallel to the shore. Yep, that's how you get back in. Yes, exactly. So a current can push you along if you're going in the same direction as it. And that's what happened. That's why they made better time on the way back because they were going with the current. On the way there, they had to push against the current. So the water was pushing them and they were just going along with their little boat, okay? And that's why it took more time. So just kind of an explanation with that. Now, that also explains why we moved faster going downstream. We had a faster speed in our boat. Speed, remember we talked about this last week. Our distance formula was distance. Let's write this guy down. Equals rate times time, okay? Because we're talking about distance, I have a time, and they gave me a rate. They gave me the speed, okay? So we're going to use that to help solve this. So down here, we're going to put R equals, and over by my other t, I'm going to put R equals as well. If I'm going 3 miles per hour faster downstream, I don't know how fast I'm going for either one. So upstream, I'm going to just leave it as R because I don't know it yet. If I'm 3 miles per hour faster, what would I do with that R? Would I take 3 away? Would I add 3? Would I times it? Would I divide? I heard somebody say it. Oh, not times. Add it. So we can call it R plus 3. If you wanted to use X, that's fine. Okay? Now, the boat went to a location and then went back. Their distance, is that a different distance that they traveled? No, it's the same exact distance. So what we can do is we can actually set these guys equal to each other. For a distance, we have to take our time and multiply it by the rate. So I'm going to take the time for upstream, which is 4 times R. And I'm going to take the time and rate for downstream, which is 2.8 times R plus 3. And then we set them equal because their distance is exactly the same. It was just their rate and their times were different. Okay? Now we can solve. Let's distribute like we've done before. We're going to distribute 2.8 times r, 2.8 times 3. What's 2.8 times 3? 8.4. Thank you. All right, I have r's on both sides. I want to move the 2.8 r. I want that to become 0 r. How do I make 2.8 r become 0? Subtract it. 2.8 r minus, bless you, 2.8 r. What's 4r minus 2.8 r? 1 point what? 2r. Thank you. And I still have 0r plus 8.4 is just 8.4. The last thing to do, divide. Divide it by your 1.2. Check with your neighbor. Make sure you guys have the same calculation answer. And then I'll ask for it. So, 7. R was our what? Was our distance, our time, or our rate? Rate. So that's how fast we were going. What was their question that they wanted to know, though? How far? Okay. So we have one more step to do. And I'm going to use the easier one of upstream. If it took me 4 hours and I was going at 7 miles per hour, what do I do with the rate and the time again? Times it. What's 4 times 7? 28. So distance is equal to 4 times 7. And so distance equals 28. Yep, miles. Awesome. So we would say, how far does it go? The boat went 28 miles. I could have used the downstream as well. I just would have had to do 7 plus 3. That's 10 miles per hour. And then times that by the 2.8. We still get 28 miles. Okay? Because they went the same distance. Turn the page. All right. Talking about a cheetah. A cheetah is running 85 feet per second. And it's 150 feet behind an antelope that is running 55 feet per second. How long will it take the cheetah to catch up to the antelope? All right. So we're talking about a speed again. That's a rate. We're talking about, they're asking for time. Okay. And they gave us a distance. So again, we're going to use that distance formula. D equals R times T. D equals RT. That's what we're using. All right. So the cheetah, how fast is he going? 85. Okay. Cheetah, 85. Okay, that's our, do we know how long he's been running for? No. Do you want to just keep it as T? Yeah. T for time. I'm good with that. Okay. Now, it says, how long will it take to catch up to the antelope? So when it catches up to the antelope, is their distance equal or different? Equal. Good. Okay. So cheetah's going to equal antelope at some point. How fast is the antelope going? 55. Do we know how long they were running for? No. No, not yet, right? 150 feet, though, right? Makes sense. The cheetah's behind stalking the antelope. The antelope's ahead of it, okay? If the antelope has an extra 150 feet in its distance, what would we do? Plus 150. Good. Awesome. Let's solve it. Get our t's on one side. So I'm going to subtract 55t. Subtract 55t. Keeping the equal signs lined up. What's 85 minus 55? 30t. Good. Equals 55t minus 55t is now 0t plus the 150. Last thing to do? Divide. I ran out of space here, so what I do to keep organized, I draw an arrow so I don't lose track of what I'm doing, and then I just write my next step up here. Okay, so we had to divide by what? 30. Good. Oh, what's 150 divided by 30? 5. Nice. So how many seconds? 5 seconds. Okay, so we could say it takes the cheetah 5 seconds. And you could say to catch up or to catch the antelope. The sentences kind of vary slightly. Yes? Okay. Two shops rent pairs of skis for a rental fee plus a fee per hour. How many hours must a pair of skis be rented for the total cost to be the same? Box or circle or highlight. Total cost to be the same. Does that mean they're equal or unequal? Equal. Okay, so our main goal is to see when is shop A equal to shop B. That's what they're asking. And I have more information here because they didn't really give me anything besides, hey, make sure they're equal in there. So we're going to look at shop A. What's the rental fee for shop A? $5, okay? That means that's a flat fee. That doesn't change. It's automatically $5 right away. And then how much do they charge per hour? $4. Do we know how long we rented it for? No. You want to use X or H? H. Let's do it. So to write this as an equation and not just in a box, write 5. And would we add the fee and the hourly together? Yep. So plus 4. We don't know the hours. Sorry, you told me to use H. Okay? So I have 5 plus 4H. 5 from the rental fee plus the hourly fee of 4 times H. We have to multiply it by the number of hours. I just don't know what they are. That's why we have to have 4H there. So do the same thing with shop B. What's our rental fee? $8 plus our hourly fee times, do we know how many hours? Nope, so we do plus 3H. Now we're set up. Solve it. I got a variable term and a constant on both sides. I don't care which one you move. I like to always move the smaller one. So that's what I'm going to do. If I want to make that 3H 0H, what do? Subtract 3H. Good. Do that from both sides of your equal sign. Okay? So now I have 5 plus 1H, which is just H, right? Equals 8. I ran out of space here. I'm going to draw my arrow. Minus 5. Minus 5. Good. H equals 3. Awesome. Fill it in right there. They already wrote the sentence for you. So, yay. The total costs are the same when a pair of ski is rented for 3 hours. So once you hit 3 hours, it really doesn't matter. I'd probably go to the one that had the better ski quality skis or the one that had less wait time to check out. If they're the same, nothing really matters except for some additional factors, okay? Let's do number 10. I want you guys to try number 10. It's really similar to number 9, okay? One more. Number 11, okay? I like pictures for this one too. The other one already kind of had a picture. This one, whenever we're talking percentages, sometimes it scares people. It's not as hard as it looks, I promise, okay? It says 1 serving of granola provides 4% of protein you need daily, okay? We should box that or highlight if you have a highlighter. You must get the remaining 43.2 grams from other sources. Okay, we should probably highlight or box that. And then it says, how many grams of protein do you need daily? All right, so that's the final question. So I have 4%. Let's make a little box and write 4% up there. And then it doesn't say 43.2%, does it? It says 43.2 grams. Those are 2 different units of measurement, so they're not giving you the same, all right? They're still talking about the total protein, so let's make a longer rectangle attached to it. And on the inside, we'll write 43.2 grams. I'm not writing it above because that's not the percentage, okay? Do you understand that part? So if I have everything, what percent do we have? 100%. If I take away 4% of that, what's left over? What percentage? I heard somebody say it. 96. Okay. So we can safely say that 43.2% is 96% of our protein we need. Okay? Because that whole thing has to add up to 100%. Are we okay there? All right. All right. So have you ever found the percent of a number before? Do you guys remember doing that? Maybe. Do you remember what operation you guys used to find a percent of a number? Ooh, multiplication. Ding, ding, ding. Ah. Okay, so whenever they're asking you for, in this case, 4% of something, blank, okay? That of actually translates to multiplication, okay? So this just means multiply. Now, I can't multiply just with the 4% as it is. You have to change that percent to a decimal version. I think that's where some of you guys were thinking division. What do we have to change? Like, how do we change from a percent just to a decimal version? What do we have to divide by? 100. Ding, ding, ding. Good. Okay, so we're going to take 4 and divide that by 100. And what do you get? Good, 0.04. So we're going to take this 0.04 and we're going to multiply it with blank. Do I know the blank? No. Can we just make it x then? All right, let's do it. That's going to be our x. So we can write it as 0.04x plus my 43.2, okay, because that's the grams, right? And that's going to equal x, actually, also, because x is my missing piece that I don't know in total grams, okay? So this total piece is my x that I'm missing. 4% of that total amount would be 0.04x. We got to multiply it. We know the 43.2, so we're good there, okay? So let's get all the x's on one side. If I don't want the 0.04x, how do I make that 0 x's? Not divide, minus. Good. Subtract 0.04x minus 0.04x. This gives me 0x plus 43.2, which is still just 43.2. That original just single x by itself, what number is really there in front of it? 1. So what's 1 minus 0.04? On 1 minus 0.04? No? 0.96. Hey, look at the percent you guys found before. What percent was up here with the 43.2? 96. If we knew enough about our percents, we could have hopped straight to this step. But I know we had to review a little bit, and that's why I didn't want to, okay? But it all connects, so kind of finding those patterns and such. Last thing to do is just divide by the 0.96. Go for it, okay? That gives us 1x, and then what's the total amount of protein we need, guys? 45. What's the unit of measures for that? Grams. So we'll say I need, because it's asking you need, I need 45 grams of protein daily. You got plenty of space here. You got plenty of space on page 29 for homework. Remember, you're either writing it in your yellow notebook for your homework stuff or you're writing it in a notebook with lined paper. I don't care which one you choose as long as you choose one, okay?